Okay, finishing up example 2, part A. I've drawn on my graph, I used every 2 squares for a pi by 4. And so you can see that that scale continues here. That means every 4 squares is a pi by 2. And I've drawn the box on and then just drawn the curve in and continued that out there. Now remember, we're not all perfect at drawing those smooth curves through the points. Make sure that I can see your key points. That's what I'm really marking, right? Those key points, hopefully you can see those on my graph. I want to see them on yours. All right, part B, g at x equals negative sign of pi x by 2. Now, this is the same as writing, I can rewrite this. The x is the variable. I can pop that out of the fraction. Since it's in the numerator, I can just write it beside the fraction. So this is the same as pi by 2 times x. So you can think about it as a multiplier. Throw brackets around that if you want. And so the pi by 2 is the k value. Here we're using x instead of theta, and then negative 3 is my a value. So again, I'm going to start with a rough sketch of the box. Terrible on an angle there. It's fine because it's just a rough sketch. I'm going to start with my vertical values. Again, the middle value is the c value. There's no c value in this example, so it's 0 for my c value. And then I'm adding and subtracting the amplitude. So the a value is negative 3. That means the amplitude is positive 3. So I'm adding 3 and subtracting 3. Now, I'm not joking. Someone is going to tell me that it's negative 3 above and positive 3 below because they're going to be adding and subtracting negative 3. Don't be that person. So you're adding and subtracting the amplitude, not the a value. The amplitude is positive 3. Okay, across the bottom of the box, we're going to have 5 key points. We're cutting the box into quarters, but there's that extra guy because we labeled the start. Here, there is no d value, right? There's no extra set of brackets. There's no adding inside with the x. So the d value is still 0. We need to figure out, well, what do we count by? And this is going to be your favorite. When the k value has a pi, it's your favorite thing that can happen. So let's see what happens. The period is always 2 pi divided by the k value. So 2 pi divided by pi by 2. I know you're groaning because you're like, oh, divided by a fraction. Just remember, just rewrite it. So instead of dividing by pi by 2, I'm multiplying and then flip it over. So it's 2 over pi. And then the beautiful thing happens. You have a pi on top and a pi on bottom, and it's all multiplication, so they cancel out. And you're just left with 2 times 2. So the period is just 4. And it's the best thing. So what that means is I'm going to have a key point every, and so you can think about that too. I'll just come up here. There's going to be a key point every period divided by 4. But that's just 4 divided by 4, which is just 1. So that means that across the bottom of the box, I'm just counting by 1. And we love having a pi in our k value, right? That's our favorite thing because it means that it's going to get rid of the pi's for us. It won't always come out to like a whole number. Sometimes you might be counting by halves or something like that, but it will eliminate the pi for you. All right, so now we have to decide, well, what's the shape inside the box? So you can add in your axis if you like. This time we have a sine curve, so I know that it's going to start on the axes, end on the axes, and in the middle it's going to hit the axis again. Now I just have to figure out, is it going up and then down, or is it going down and then up? So this sine curve has a negative 3 in front, which means that there's been a vertical reflection, and this guy goes down and then up, right, because of my negative a value. And now I just have to sketch that. So I'm going to throw my axes on here. This one's nice and easy because I'm not even going to have to worry about counting by pi's. I need to make sure I can see up to 3 and down to negative 3. And then I need to see 1, 2, 3, and 4 really clearly. Remember that I do want to see 2 full cycles of the graph, so you got to make sure you get over to 8 when you do this. So I'm going to count every 3 squares as 1. I'm not going to label every single one, but enough that Somebody reading my graph doesn't have to count out 20 squares to figure out where you're at. This one's got an x in it instead of a theta. And then I'm just labeling my key points. Again, you can add the box to your graph if you want to, but you don't have to. Adding all my axis values, and then I'm going down and up in between them. And then just drawing your smooth curve in between. Just pretend that worked out for me. And that one too. Okay, because we want to move on. All right, example 3, finding the equation of the function. So this is just going backwards from what we've already done. In our first example here, they're giving us the characteristics or the properties, and we have to find the equation. So our job is to determine the equation. It says that the parent function is cos, so that's important. And it says that there's no horizontal translations, so the d value is always 0. And there's no reflections in either axis. So the a and the k are both positive, is what they're telling us, but no d value. So that tells me then that my functions, don't forget, they already used f at x up, so I can't reuse it. I'm going to call this guy g at x. It tells me that my functions look like a times cos, because they told me the parent is cos, times k x plus c. And there's no extra set of brackets with the plus d because it's gone. No horizontal shifts. Okay, so now we have to figure out what's the a, the k, and the c. Well, the a value is going to come from the amplitude, right? So the amplitude here is 5. I have to think about, is it positive or negative 5? But this question says there's no reflections, so it's positive. Then I have to come up with the k value. Now the k value is the hardest part. The k value is going to come from the period. So I know that the period is 3 pi. So I'm just going to come off to the side here in my rough work. I'm going to remember that the period, so remember, if the period, we already know this, is 2 pi divided by the absolute value of k, well, then I can rearrange this and solve for k equals, because here I want to find k, right? So I'm going to just rearrange this. I'm going to bring the k up to this side here, and at the same time, so I'm bringing the k up, the 2 pi is still there. At the same time, so now I've got k times the period over here, but I'm going to bring the period over and divide it on the other side. You can step that out if you want. You're just rearranging this, and it turns into this every time. So k is 2 pi divided by the period. So k is 2 pi divided by the period is 3 pi. And so I can cancel out the pi since it's all multiplication, and I can see that the k value is 2/3. So in my equation, I'm going to have 2/3 times x. I'm not flipping it, right? I already flipped it when I did dividing by the period, right? Or dividing by k here. So I've already done the flipping when I figured it out. And then plus c. Now remember, the c value is just your axis. That's my vertical shift up or down. So -2 at the end. All right, the next one, the graph has a period of 6 and an amplitude of 3/4. The equation of the axis is y equals 15. So same idea, we're starting out, we got a different equation, so I'm going to give it a different name. We're starting out with no d value. And I just have to fill in what I know here. So I'm going to start with the a and the c because they're the easiest ones. The amplitude is 3/4, so that tells me the a value is 3/4. If this was a more complicated question, I would have to think about the reflections, but there are no reflections here, so 3/4. And then the k value, I'm going to leave that for a second. The c value is comes from the axis. The axis is y equals 15, so the c value is positive 15. All right, so let's go and figure out our k value. The k value comes from the period. K is always 2 pi divided by the period. I dropped the absolute value bars since I know that k is positive anyways, because there are no reflections. So we're going to do 2 pi divided by 6 and I'm going to reduce that to lowest term, so 2 over 6 is the same as 1/3, so the k value is pi by 3. And then I can just pop that in, pi by 3 over x. And so of course I would show this rough work in my solution because it's valuable rough work. All right, example 4, determine a sinusoidal equation for each of the following graphs. So we're given a picture, and the tricky part here is with there are an infinite number of answers. There's only so many that you would probably come up with based on the chunk of the graph that I've shown you. But notice that there's lots of different d values that are possible. I could think about, oh, I shifted and started over here, or I shifted and I started over here. The other thing is it says sinusoidal, but sinusoidal could be cosine or sine. They're both sinusoidal. So I don't know which one it is. I get to choose. Depending on the curve. So what am I going to do first? I'm going to start with the axis because I always think the axis is the easiest. So I'm going to draw in my axis here. Ooh, I might use a ruler if I were you. And I can see that my c value of my, because remember I'm trying to come up with the equation, the c value is the same as the axis number. So the c value is -1. And then the next thing I'm going to do is look, so I always start with the vertical stuff, right? The a and the c. So this, because I know my equation is going to look like, I don't know if it's, I'm going to use cos or sine yet. I haven't decided. So it's going to be one of those two, and then I'm going to have my k, and then my x minus d, and then plus c. So I've got my c value. The next thing I'm going to do is worry about my a value. My a value comes from my amplitude. So I can look at the amplitude in lots of different places. I can see it here. My amplitude is equal to 2. Or I could have seen it here. My amplitude is equal to 2. So I know my a value is 2. I don't know if it's positive or negative yet, though. So I'm going to put some absolute value bars on that. Now, in order to come up with the horizontal values, I have to decide, am I going to start on the axis or start at a max or a min? If I'm starting on the axis, then I'm looking at a sine curve. If I'm starting at a max or a min, I'm looking at a cosine curve. So when I look at the max and the min values, what I notice is that they happen not on a grid line. So they happen kind of in this mystery space between -pi and -2 pi by 3. I think it's halfway, but I'm not sure, right? It could be really close to half, but not quite. So I'm not going to bank on those numbers there. So I'm not going to use a cosine for this because the max and min are not on the grid lines. I'm going to look at the axis values. The axis values actually hit the curve on a grid line. And I'm going to pick one of them as my starting value. This can be different for different people. I'm going to start at this one here at -pi by 3. But somebody else is going to get a similar equation to me, something a little bit different, if they started at -4 pi by 3. Or somebody else is going to get a different one if they started at 2 pi by 3. These would all be valid answers. All right, so we've decided I'm going to use a sine curve. Notice that from my starting point, the curve goes up and then down. That tells me that the a value is positive. So the a value is in fact +2, and I'm going to use a sine curve. Okay, what else do I need? I still need my k value. My k value is still a mystery, but I do know that my my d value is -pi by 3 on the graph, so +pi by 3 in the equation, and then -1 for my c value. Okay, got to figure out my k value. So I know my k value is 2 pi divided by the period. Okay. So what is the period? I started at -pi by 3. Notice that, so there's a couple of different ways you can do this. I'm going to just use counting squares to figure out the period. I started at -pi by 3, and I go over 1 square. 1 square is worth a pi by 3. So I went 1 pi by 3, then a second square, 2 pi by 3, 3 pi by 3, 4 pi by 3, 5 pi by 3, 6 pi by 3. This is the end of the first cycle. And it took me 6 pi by 3 squares. So the period was 6 times pi by 3. And if I multiply this together, I get 6 over 3, I can reduce that. 6 over 3, that's the same as 2 over 1. And I can see that my period is in fact 2 pi. And actually nothing has changed. So my k value, 2 pi over 2 pi, is just 1. You can write that 1 in, or you can simplify this equation and just write, the brackets are required though, at least one set of brackets here. Another way that you could have calculated the period is to take the ending value, 5 pi by 3, and subtract the starting value, negative pi by 3. But notice there I'm subtracting in negative, so I'm actually going to add those things together. So I get 5 pi by 3 plus a pi by 3, which is, again, just like up here, 6 pi by 3s, and you would then reduce that to 2 pi. Okay, so same idea, just one counting and one using a mathematical formula. All right, our second example, we're going to look at this curve here. Again, I'm going to start with the same idea. I'm going to draw in my axis first. So the axis in the middle of the curve. It's going to tell me my c value. Then I'm going to look for the amplitude. Again, I haven't decided yet if my a value is positive or negative. The next thing I need to do is move on to my my horizontal values. So I have to pick a starting point for this curve. The starting points are either going to be on the axis. That looks gross because I can't really tell, like, what is that, 1 1/3, 1 1/4? I'm not really sure. So I'm not going to use the axis values. I'm going to use the maxes or the mins. Now when I look at the mins, it's also not on the grid line, so I'm not going to use it. I'm going to use one of these maxes. So I'm going to use this guy here. You might have used this maximum here and you'll be fine as well. You'll get another alternate correct answer. So using that value here, that's going to be the starting point of my curve. So my d value is going to be -1. It means it's going to switch in the equation, right? It'll be +1 in the equation. All right, so let's start to put together some of our pieces. I know we haven't talked about k yet. G at x is going to be, just like last time, a, and then it's going to be sine or cos, and then it's going to be k x minus d, oops, plus c. All right, so we've decided that our a value is 1. I need to figure out if it's positive or negative, though. So if I start at a maximum, I'm looking at a cosine curve. And if I start at a max and then dip down, that's a positive cosine curve. It hasn't reflected. So I've got a positive cosine curve, so it's +1, and then cos, and you don't have to write +1, you could just dive right into cos. Then we need our k value, and then I'm going to see an x plus 1 for my d, and then c is +2. All right, so k value, the thing we don't want to do, right? The k value is how long did this whole first cycle take? That's gonna tell me the period. So I went from -1 to 2, so you can count squares, 1, 2, 3, or you can do 2, subtract -1, so 2 plus 1 gives you the 3 as well, just like above. So my period is 3, so that tells me that my k value is going to be 2 pi divided by the period, or 2 pi divided by 3, and then I just pop that into the equation. Remember that whenever your x-axis ends up with no pi's, it means that your k had a pi in it. And so I can clean this equation up and just say that it's cos of 2 pi by 3 times x plus 1. And that k value, of course, is factored in. All right, and that's it for lesson 6.4. Enjoy your homework.